Okay, so number 1, you should have 3 over x.
Did not do that. I got 3 natural log of 4x.
Well, because your u should be 4x cubed.
Mm-hmm.
And so u prime should be 12x squared.
Yep.
So then it should be 12x squared over 4x cubed. Reduces down to 3 over x.
Is this the u prime over u?
Mm-hmm, because it's natural log. So the derivative of natural log is u prime over u. Okay. So on 4, your u would be 2x and u prime would be 2. So using the natural log does not work on the 4, does it?
No.
No. And so you have to rewrite it as x to the negative 1, natural log of 2x, and then use your product rule. This is one of those be creatives.
See, the thing is, though, is that if I'm being creative, then I still get the wrong answer. Because there's so many ways that you can be creative.
Mm-hmm.
So how am I supposed to know if I get the right one?
Well, starting on this test, you'll be able to have your derivative rules. Okay, your derivative integration rules. And when you hit here, and I can't use natural log, so my choices immediately go to quotient or product, doesn't
Why
it?
can't you use natural log?
Because natural log, you have to do u over u prime.
I thought it was u prime over u.
Or u prime over u, sorry. But you have this x down here. Like, you have that x. If it was without the x, you could do it. But I have to account for it. So I either have to write it as x to the negative 1 and make it a product, or I could leave it and do a quotient, which I don't want to do a quotient. I'm basically end up with a quotient anyway, but I didn't want to do one.
So basically, with fractions, you can't use a natural log.
Not usually, no. Now, if it was the natural log of 2x over x, like of that whole thing, you could have.
Natural log of 2x over x, that's the same
Like,
thing?
no, the natural log of 2x over x, but that would be just 2. But you know what I mean. Okay. Can we go on?
Yeah.
Okay, so the next one, there's 2 ways you could have done it. When I first did it, I did the, what did I do?
Did all of these wrong.
No, wait, stop. Okay, so when I first did it, there's 2 ways you could have done it. When I first did it, I did a long, hard way. Like, u was this whole thing in here. Mm-hmm. And I had, in order to do that, I had to use the product rule. See that? I had to use the product rule. But look what if I would have just done if I would have just done break it up. Mm-hmm. Because since this is multiplication, I could make it natural log of 2x plus 2, that exponent, natural log of x plus 3, and then I could have done it really easily.
Yeah, I still did it wrong.
Did you do it like this?
No, I didn't do any of this.
Okay. But do you see how I got the same answer, but this second way, using my properties, made it so much easier?
Yeah.
You want to go over that? Like, okay, so when I did it the first way, I saw, okay, well, u would be 2x plus 3 quantity squared, wouldn't it? Yeah. And then u prime, I would have to use the product and the chain rule to get it, and I did. Or I could have just broken it up. So when I multiply, what do I do with my logarithms? Add them.
Yeah.
So I'd have the natural log of 2x plus, and this exponent can come out in front. So 2, the natural log of x plus 3. So I'm going to have two u's. I'm going to have u is 2x, and I'm also going to have u is x plus 3, because I'm going to do the derivative separately on both.
Mm-hmm.
Okay, so then here u prime would be 2, and here u prime would be 1. So I'm going to have 2 over 2x plus 2 times 1 over x plus 3.
Okay.
So this reduces to 1 over x. This 2 is going to go right there, right? And now I should get common denominators. So my common denominator is going to be x times x plus 3.
Wait, why is it x?
Because I have 1x here, and I have x plus 3 here. So I have to multiply 1 times x plus 3. Am I going too fast?
No.
Okay, so 1 times x plus 3 would be x plus 3.
Yeah.
And 2 times x would be 2x. So
Did you just multiply the top and the bottom?
I just multiplied this by x plus 3. And I multiplied this by x. Just to get common denominators. So that gives me 3x. It would be 3x plus 3. So it'd be 3x plus 1 over x plus 3.
Wait, why is it x plus 1?
Because this was x plus 3, so I just factored out a 3.
Wait, what?
When I combine x plus 3 plus 2x is 3x plus 3.
How?
X plus 2x. So then I have 3 times x plus 1.
Over x.
Times x plus 3. Okay. So with 5, you had to use the product rule. Because you have x squared times the natural log of x. So the derivative of x squared is 2x times the second plus the first times the derivative of the second. Either way, this way or this, I'd take. Factored out that x, it just looks better.
Wait, so the derivative of x is 1 over x?
The derivative of natural log of x is 1 over x. Because u would be x, and the derivative of x is 1.
And then why is the x just x? Like,
Here, because you have x squared divided by x, would just be x.
and then you just multiplied it? Or
I factored out, because there's this x here and this x here, so I just factored out an x.
and why is it plus 1?
Because x divided by x is 1. You struggle with that. You usually want to take it away, don't you?
Yeah.
Okay, so number 3, we should use our rules. because it's together and it's division, so I can make it natural log of x minus the natural log of x plus 1.
Okay.
And then just take the derivative of each of those. Did you forget about using your rules?
No, actually, this one I used my rule.
Okay, did you get the right answer?
No, because I didn't simplify it.
Oh.
I just had L natural log of x minus natural log of x plus 1.
Oh, you just didn't find the derivative, you just stopped.
Because that's... I don't know why. I don't know why. That's what I did on every single one of these. I didn't find the derivative.
You just used the rule and stopped?
Yeah, that's just what I did.
Hmm.
And then you just multiply it. Like,
Yeah, I multiplied this by x minus 1 and this by x. And then I combined like
you mean
terms.
x plus 1?
Oh, yes. My hand was over it, I couldn't see it. Would the x be negative? Mm-hmm. So it's right here.
No, like I'm talking about the denominator. Or no?
No, this, because of that,
Yeah.
I would put it with the 1. You put it with one or the other. But if you put it in the denominator, it has to be a negative x and a negative 1, and that has a whole different set of stuff. I just like my negatives in the numerators.
Well, I just thought that it went with everything.
No, it has to go numerator or denominator. Because if it went to both, they'd be positive. Because a negative divided by a negative is positive. Okay. So then, integration, right?
Yep.
Okay, so u would be the denominator. We're hoping, right? So 4 minus x cubed. So du would be negative 3, or u prime, whichever, negative 3x squared. So we're good, except we need to multiply by negative 1/3.
Mm-hmm.
So once we have that, we just have negative 1/3 the natural log of x minus x cubed plus c.
Okay. Do you know how many times I just wanted, like...
Are you talking about 8?
Yeah.
Do you see what I did?
Yeah, and I don't get it. Because mine didn't match it.
You what?
Mine didn't match it.
Okay. Well, the reason why I knew I couldn't do natural log, first of all, is because the derivative of 4x would not be x to the 5th, would it? So dividing both of these by x to the 4th allowed me to break it up and just deal with them separately. So I have x to the 5th divided by x to the 4th, just gives me x.
So wait, why do you divide them up?
Because I knew that the derivative of x to the 4th was not going to be x to the 5th. That's not the way derivatives work, is it? So, and I can. The denominator is one thing. I can split it up from that numerator. So I can just make it easier to deal with. So I have x to the 5th divided by x to the 4th plus 1 over x to the 4th. So then I have the integral of x plus, now 1 over x to the 4th would be x to the negative 4th, wouldn't it? And then I just integrated them individually. That's just back to a normal integration problem that we've been doing.
I don't get it. Why?
Yep.
Well, how do you get like half x squared?
Okay, because when I integrate, there's a 1 here, yes? So 1 plus 1 is 2. So it'd be x squared over 2, which is the same as 1/2 x squared. And then this would be add 1, so it'd be negative 3. So the negative 3 would go to the denominator, so x to the 3rd, and it'd be negative 1/3. And I don't know why I put 1, 1, 1, and 1, because if I would have just put it x squared over 2 minus 1 over 3 x cubed, it would have been easier to see my common denominators. So my common denominator would be 2 times 3x cubed, which gave me 6x cubed.
What do you have to...
So I have to multiply this by a 3, and I have to multiply this by a 2. Oh, 3x cubed, sorry. And I have to multiply this by a 2. So 3x cubed times x squared would be 3x to the 5th minus, and 1 times 2 is 2.
I don't even think Sadie knows that.
Okay, I didn't say anything. Okay, next one. So u would be x plus 1, du would be 1. So I just have to pull out a 6, right?
Yeah.
Yeah, because it needs to be 6.
Oh my god.
Did you forget to pull out the 6?
Well, no, I just put a 1 6. But I don't know why.
Because normally if you needed a 6 and you didn't have one, you'd put 1/6. Well, this time we need the 6.
So, this is not good.
The other way you can think of it is this. You could have immediately, before I even did anything, pull it out.
Why?
Because a constant, anytime you have a constant, you can pull it out. So 6 would be a constant, right?
So then if we pull it out, wouldn't it just be x plus 1?
So
whatever
x
we
plus
have.
1 is u, and then du is 1. So I have u prime over u. So it's just 6 natural log of the denominator of u. Okay. Next one.
Yep. I got Ellen 3. That was 1 off.
So u is x minus 3, and u prime is 1. So it'd just be the natural log of x minus 3 from 7 to 4, 4 to 7. So then you plug in 7, 4 minus 3 is 4.
Mm-hmm.
Plug in 4, 4 minus 3 is 1.
Yep.
So what is the natural log of 1? 0?
Yeah.
Yeah, you can't subtract these two. Well, here's another way to think about it. What does subtraction mean? Division, right?
I guess.
Well, I mean, it does with the condensing and expanding rules. So if I condensed, watch this, it'd be the natural log of 4 divided by 1, which would be what? 4?
Yeah.
Okay, so this one's a little bit more involved. It's a little trickier again. How did I do this? I divided them again, didn't I? I took 5x over x squared plus 1 over x squared. Because again, u would have been the denominator and the derivative of x squared would not be 5x plus 1, would it?
But it would have been 2x.
Yeah, but it wouldn't have been 5x plus 1. I can't deal with the plus 1.
Yeah, you can. You can just add add a 1.
No, you can't do that. So I divided the 2 and came out with, because this would reduce to 1, so I have 5x to the negative 1 plus x to the negative 2 to bring it up. So then here I'd have 1 over x, which is natural log. So 5 natural log of x. And the integral of x to the negative 2.
Wait. 1. So.
Those are horrible integral signs. Looks like an S.
So, how do you get 1 over x from?
Because
X
this
to
right
the-
here is 1 over x. Correct? X to the negative 1.
Yeah. And then x to the negative 2 would be.
You'd add 1, so it'd be 1. So it'd be a negative.
Yeah.
And so it'd be x to the negative 1, which would be 1 over x.
Wait. You just kept x to the negative 2? You didn't do anything?
No, because x to the negative 2 isn't going to be able to use the natural log rules. Because, look, this right here is something we just dealt with. Because if I have 1 over x squared, if you wanted to try natural log, it'd be u would be x squared, and then u prime would be 2x. Well, that's not 1, is it? So the natural log rules don't work on it. So I just use the basic integration of adding 1. So I had x to the negative 2 plus 1. So that'd be negative 1, so it'd be over negative 1. So I get x to the negative 1, negative x to the negative 1, which is negative 1 over x.
So then what happened to 1 over x?
It's right there.
No, I'm talking about the other one because.
Well, what's the
5
integral of 1
natural-
over x?
X.
X would be u. U prime would be 1. So it's natural log of x. It fits the natural log of x. Mrs. May? Hey. Is she okay? Okay. 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 Thank you very much. Okay, bye. Okay, I am just going to put this up here, and I'm going to move slow, and you can watch on the video. But this one says just set it up. So this was the problem right here. Mm-hmm. So you just set it up. You're going to take the integral from 50 to 75. And 1/25th because... per hour. Do not evaluate. And the reason why there's 1/25th, I can't remember. I have to go back over that. But you just set it up. I have to think about that. Okay, these two down here, we were just using our basic pre-algebra. Subtract 7. Once you subtract 7, you get 5. Divide by 3. And then I have to take the natural log of 5/3 equals 2x. And I have to divide by 2, or in my case, I multiplied by half. Okay, over on 13, it's already, all the natural log is by itself, so the base is e, so e to the third equals 10x, divide by 10, so x equals e to the third over 10. Okay, next one, you're supposed to find the derivative. So u, I didn't write down u's, and I should have. U is 2x plus 8, right? So u prime is 2. So so I have 2. And then 15, you have to use the quotient rule on 15. So I had to find the derivative of the first times the second minus the second times the derivative of the first divided by, or denominator squared. Okay, then I have integrals.
Yep.
So I'm just going to put it here. And can you see the bottom one?
Yeah.
Okay, so when I said there wasn't a whole lot of work, there wasn't a whole lot of work. So
Okay, wait. Why'd you change that to, like where the 4x was? Why'd you change it to 2?
why'd I change this to 2?
Yeah.
Okay, because it's 4, but the derivative of x squared plus 3 is 2x.
Yeah.
So there had to be an extra 2.
I know. I understand how you got the 2 out, but the 2 in the inside of the integral.
Because this right here
Yeah.
would be the derivative, the whole derivative. So I just separated this 4 into 2 times 2 and brought out one of them.
Okay, so let's say there was a 6 in the 4's place. Would that?
So
turn
this
into
would be
a
a 3 and this would be a 2. Yes.
Oh, could it be the opposite way, like the other way around? Could it be a 2 and a 3?
No, not unless this is a cubed. If it was x cubed, it could. But to fit that derivative, the 2 has to stay in.
Okay.
Okay?
That's confusing.
So I will post that video and you can look at them